Welcome from my end here in Germany. It's 6 p.m. In the afternoon for me. For my amazing colleague Ronan, it's even deep down in his night. He's sitting in beautiful Japan. We welcome you to this introduction to Keil Studio Cloud and some cloud-based development for IoT and embedded applications. This is an interactive workshop. Some of you have received some hardware that we are going to play with. Nevertheless, I have just a couple of slides that I would like to share with you. So what is this all about? We are talking here about seamless support for all development phases. So basically what this tool that you learn to use today is envisioned for is to check or to discover possibilities from the hardware and from the software point of view, and explore reference designs, find out what code is out there that you can use to make your next development project run faster. And we are helping you in these first two phases with Keil Studio and the web platform that we're going to use just in a couple of minutes. If you later continue with your development voyage, we also have offline tools, desktop tools that you can use to further develop the application and to get better debugging experience, find better ways into finding bugs, and finally, of course, also deploy to custom design, to your custom design. Let me just quickly summarize some of the key advantages that we offer here with this cloud-based embedded development tool. So first of all, being a software as a service, this is a great step forward because you actually have nothing to install. So it runs from the browser, everything is set up by us. The overall IDE is as is. And you can develop on multiple platforms. I think we will be having Windows, Linux, and macOS users today. And basically, it does not matter which operating system you are using, as long as you are using a Chromium-based browser. Then, of course, later in the development phase, if you have your IoT device, then over-the-air programming, of course, helps you to keep your firmware up to date. Of course, also to fix some bugs that might be just out there in the wild and you want to fix them. You can enable data analytics where you basically monitor your devices and try to find out what's wrong with your overall setup. And you can then use, for example, ML algorithms, or you can use this data as training data for ML algorithms. And again, with over-the-air updates, you could, for example, even exchange your ML data model or your neural network or whatsoever. And then finally, again, coming back to the development, using servers in the cloud, you can easily do continuous integration tests. You can run on simulation models. I hope you have all learned about our awesome news of ARM virtual hardware that we just announced yesterday, and which is also part of another workshop on Dev Summit tomorrow. So all of this enhances your development speed, and I have a link here in this slide deck where my awesome boss, Reinhard Keil, has wrote a blueprint blog that explains more about cloud-based embedded development using ARM. So how does this workflow basically look like? We have continuous integration in the cloud. You have, for example, things like GitHub runners that can automatically trigger GitHub actions. Once you commit some code, your test results will be presented to you automatically. You have this dashboard, the cloud IDE in the browser, Keil Studio, which you can either connect to your local hardware or in a later stage, not today, can also, for example, connect to this virtual hardware. And then, as I said before, if you want to continue on a desktop tool, we have exchange mechanisms so that you can connect to a classic tool like, for example, MDK or RMDS. All kinds of debug adapters that you can use for example, power analysis, which is especially important for IoT devices, of course, or other debug adapters like Ulink Pro, where you can do full code coverage if you're more to the function safety arena. So we offer the full flexibility, and from the cloud up or down to the desktop tool, everything is available. So final slide before we get into action. What are we going to do today? We are going to work with this piece of hardware. I need to find the camera. Here it is. It's the Mqtt 1050 EVKB. As I said, some of you, the early birds, have received this hardware. And thanks to NXP for sponsoring us with the 50 boards. We will search for projects on our website. We will import them into Keil Studio. We will build them, of course, flash the target and also debug them. We will have a wide set of example projects. Of course, we start with the inevitable Blinky project to check that everything is set up. Later, I will show you a TensorFlow Lite micro speech application that basically recognizes yes and no's. And I hope we can make it through to the Mqtt demo application using AWS. Other thing that I hope that you all have, so the guys and so everyone with the hardware have finished the pre-work that is on this GitHub account. So this one here, the ARM Dev Server 2021 introducing Keil Studio. So we are talking about the hardware. I have a board picture here, what kind of setups you need to do before. And very, very unfortunately, very, very important is to flash the right DApp firmware, because our web IDE requires a certain debug adapter protocol being present. Otherwise, you won't be able to debug the board. So I hope you have done that. If not, you still have a couple of minutes time to do it. And I will get started.
Hey, just so before you quickly get started, Chris,
yes.
I've got a question coming in from Alex. Is the cost of cloud-based development tools the same as the desktop tools, the offline versions?
Well, currently the cloud, so we are currently in an open beta version, so it is the usage is free, and actually we, especially for this exploration phase where you just play around with hardware, with software, we tend to keep this open and free. Of course, you can think of other models like later when you go to more this CI workflow where you also run on virtual hardware, for example. But in general, let's say the first touch is definitely free, and we need to explore how we take it further.
Perfect. Thanks, Tristan.
Okay, yeah, great. So this is Keil Studio Cloud, and now please excuse me, I need to switch to my other monitor here. So this is keil.arm.com, our entry page, and where we, of course, want to go to is the hardware section. Okay, and on this hardware page, we have already listed, you see, an awful lot of development boards. So basically all development boards that are today supported by CMSIS-Packs. CMSIS-Pack is our delivery mechanism for device support, board support, and software components. I will talk about that later in more detail. And we are interested in the 1050. And basically we have here two boards listed. One of it is the original 1050 from NXP. We have created an add-on board support pack that gives more options for this development board. As you can see on the entry page, it talks which core is on the board, what kind of debug probes, which device. We have links to things like documentation, so getting started guides, quick start guides, and the likes. We have a tab about the features that are on this development board. So everything that is basically mounted, soldered, or connected on this development board is listed here. And the most important part is obviously the projects tab. And on this projects tab, you find a couple of code examples that you can use in Keil Studio right away. And what we are going to do here is first starting with the Blinky, so the number 4 from the top, and you just click on Create Project, and it automatically brings you to the login screen of Keil Studio. I select my login name here, and then it takes me through to the login, and it creates the environment for me, and then basically pulls that development project into my personal space here in Keil Studio. It takes a couple of seconds to build up. It should be finished soon. And of course, it asks me, what kind of project name do I want to give it? And I just say Blinky, so that's fine. I just say add project. Disconnect my hardware to show you that later. What it usually does, we have a README MD file that explains the background of the project, and this is automatically open so that you can review that. It says the Blinky project can be easily used to verify the basic tools setup. It talks about the operation, what can you expect to do. So of course it will blink an LED, but you can also change the blinking frequency by pressing a button. We will later debug that. What is used here, it's our Keil RTX real-time operating system. And then it talks about the development board here. So it's the NXP Mqtt 1050. Clock configuration settings are mentioned, all the GPIO configuration settings, down to SEMSIS drivers for Ethernet, whatever, and our drivers, our virtual I/O. So this is already presented when you start the project. And basically, now the magic happens. This is the development board. This is my USB cable, and I just plug it into my computer. Windows recognizes, I'm using a Windows machine, it recognizes it, and automatically also the tool will recognize that the correct target hardware is connected here. If it does not do that for you, you can use this button here. Click on that and say find target. You should see, if the firmware flashing has been done and is correct, then you should see a DAP-Link SEMSIS DAP here, and you can click on the connect button so that it connects the browser IDE basically through to your device. I just hit cancel now, so this is already done for me. Everything is fine. If you know, or if you have used MDK in the past, or another tool that is using SEMSIS packs, you know of something that is called Runtime Environment. So basically a project is made up of different software components, and we have ways of showing them. So here's a button with the managed components view. Just takes a little while to show it. So here it's not the full catalog of all software components. Currently it shows the software components that are in this project. Currently it's view only. In the future we will of course also create something where you can select and deselect software components. But so for now it's view only, but it has basically the same feature like the Manage Runtime Environment window in MDK. So for example, you could click on this documentation link here and it brings you directly to the documentation of SEMSIS Core, for example. So this is almost the same as you have it today in the desktop tool. Similarly, we have basically, how does this? Sorry. Similarly, we have the same here for the components. We have this project outline view, so you see the components that are in there, SDK drivers, or SEMSIS, SEMSIS Core, SEMSIS RTOS, Keil RTX5. And here you see all the files that are basically taken from the software pack. So they are not actually kind of on disk, but they are referenced from the software pack. But we also have another view. This is this workspace view where you are presented with a files that are actually in the project itself. So we have a main.c file, and we have for example, a blinky.c file that does all the magic with blinking the LED, and also connecting to the button. What else have we here? We have, of course, very prominent a couple of buttons here. So this is the build button, the hammer tool. This is the play button we will be later using to download something. And of course, we also have a debug button. I think it's currently shown as experimental, but it works quite nicely. And we have another button to open the serial monitor. We will use that later in the other two projects to see or to communicate basically with the target. Yeah, that's basically so far it for well, not all. We have also other buttons here on the side here, for example, for source control. Currently, there is no repo attached to that. We will use that in the other example as well. This is for the debug view, but we need to build first. We have also a settings view here. So we can, for example, control if you are connecting under reset or stop after reset, things like that. Also what you would expect from a normal IDE. So let's maybe first, check another thing. Very cool is, of course, the integration with basically the source code editor. This is using the Monaco editor, the same as in Visual Studio Code, and it also has IntelliSense. So let's say if I want to add some code here, I could say OS delay, and then I'm presented with the different options that I have, delay until, or say it even thinks, oh, have you maybe mistyped? So do you want to say, oh, a semaphore? Things like that can be easily done. Now let's do some error here, or maybe even no thing. So it's directly marked here, and it's shown that we have a problem, use of undeclared identifier OSD. This is currently, there is no quick fix available, but you see as you type, it notifies you of problems. Or let's say if we just take away this semicolon here, we can also see here in the problems window, okay, expected semicolon. It takes you there, and using the light bulb, you can even fix that easily. So this is all that comes with the IntelliSense mechanism. Other nice stuff is like, for example, I can right-click on something and say, for example, go to reference. It opens and then it shows me all references of this VIO set signal here. Closing that quickly here, I can of course also go to definition. So the SEMSIS VIO header file is opened where this SEMSIS, the VIO set signal is declared. So this is all automatically available in this environment, and really cool features that help you to code efficiently and quickly. So now let's use actually the hammer icon to build the project. And when we are now building the project, it is a process is kicked off on the server. So you see it's building really fast, 50 files, and I even can't talk that fast as it's built. And it creates a binary that you, for example, could also use. We can, for example, show in folder, and then it opens up, in my case, Windows Explorer, and I see this binary here, and it could, for example, drag and drop it to the target, but this is not what we want to do today. As I said, the play button, actually, it just takes this binary now and flashes it onto the target and automatically resets and run, and it starts working. What we actually want to do is do the debug thing here. So I hit the debug button. SMSIS build is started again. So we're using a technology at our called SMSIS build in the background. And this basically runs on the C project format file and knows all about all the SMSIS packs and does all the magic. And of course, the IDE also knows when a project has already been built, that it's avoiding unnecessary rebuilds. We saw the target has been flashed, also just takes a couple of seconds. And again, this is a browser-based IDE, web-based IDE that is now directly talking to your hardware. So, and as all good IDEs, it runs until main and stops there. And of course, as well, in good IDEs, we can set breakpoints, for example, in this VIO init here. And in the blinky.c file, I would like to set a breakpoint at line 45. And I can now just simply, of course, run, and it hits the first breakpoint, the VIO init. I can do stepping, so I can step into the VIO init function, continue stepping, steppy, 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 all that nice stepping thing. I can, of course, also step out, and it continues. And I just say continue. And now you should see that this LED close to the Ethernet connector is blinking. So yeah, and basically, if you now press this button here, very close to or in between the headers from the Arduino connector, you will see that we hit now line 45, because line 45 is only activated once the button has pressed, because it actually now changes the blinking frequency. And I can continue, it will hit again, continue, it will hit again. It's now in this, of course, in this part of the if. And now I can, down here, we have this little breakpoints window where we can manage breakpoints, enable and disable them. So for example, I will now disable this so that I'm able to actually hit the button again. The blinking slows down. And if I now re-enable the breakpoint, it will not be hit anymore because the button press has not been detected. And once I press again, we stop there. So run stop debugging out of the box with a hardware target that is connected to your PC, but all of that from a browser-based IDE. Another thing that I would like to show you is that we have also just recently, actually, I think this week, my awesome colleague Matt has included that in the IDE. We have added a memory inspector. For that, I will just quickly stop the debug session. And I go here, and I just declare a variable link count. We set it initially to 0. And let's say here at the end, I say it's blink count. And here you see again the IntelliSense in action. So I just hit enter, blink count ++, and that's it. Now, if I, of course, go to the debug mode, then of course, SMSIS build is not kicking in. I wonder if that was correct now. So usually the files should have been saved automatically in the background, and then of course it should notice that there was a code change. Oh yeah, of course, colleague reminded me. It did the build, but of course only that single file that was changed and then linked. So you see, it's even intelligent enough not to do the whole build stuff again. Again, as you would expect from any normal IDE, just running in your browser. So now let me basically put a breakpoint here. I remove this one and I run. The VIO init, I can also disable that here. Continue to run. I hit this breakpoint. And now I can check here in the variables. I can see the global variables. And here in Blinky.c, I see blink count. The variable is 0, which is expected. It has not been executed. Of course, the breakpoint always stops before the actual execution. And I can now right-click here and say, show variable in memory inspector. And now let's maybe, I remove the breakpoint and I just let it run. And then I say stop here. And then you see we can just check here once again, Blinky.c, the bin count is 6. And also here the data, if you hover over it, you see the decimal value is 6. And now the even nice and cool feature starts. You just click on it and you say 0, 0 and say apply changes. And then if I go to Blinky.c again and put here and I just rerun it, then you see Blinky is now, blink count is 0. I enable it, I run it once, and then blink count is 1. So you have even, you can inspect the memory, and you can also fiddle around with the memory. You can play with it. You can try different values, can try to kind of inject errors to do some debugging here. As I said, really, really cool feature that has just made it into the tool this week. So it seems that a couple of you have trouble with debugging. RDDI DSL error, unable to claim interface. If you are unable to claim the interface, then maybe either you have multiple windows open, so multiple windows of Keil Studio that are trying to connect to it. So try to limit to one. And yeah, I hope that helps you here. Let us maybe know through the chat. Yeah, we have. I was explaining that you have the option to use the pre-built examples from the web page, but you can also work with examples that are on GitHub. And just let me pull up another example here. So this is under github.com/keilchris/tfl microspeech, and I just where is the chat window? I just paste it and send it to everyone. So I encourage you to go to that repo and basically fork it. So fork it into your own GitHub account. And once you have done that, you can basically use your GitHub account to import it into Keil Studio. So I, of course, will use my GitHub repo here. So I just go to File, Import Project, and I give the URL. it automatically recognizes it. There is again a CPRJ project in there. I can just show you. So this is the project file, the micro speech IMX1050 EVKB CPRJ file. This is the kind of newly defined common project format file in CMSIS, which we are using in Keil Studio. So I go back and I import it. It will be made the active project automatically. So it's now importing. And we see now the TFL microspeech, and you also see again the README MD file is opened, and it presents you with all the relevant information. So what is so very special about this project? It's as the name says, it's TensorFlow Lite Micro, so the microcontroller implementation of Google's TensorFlow. And my colleague Matthias Hertel has worked a long time together with Google to make this TensorFlow Lite Micro available as a so-called IMSIS-Pack. So this is now on our index server since last week, and we are using the TensorFlow Lite Micro packs here to basically build this microspeech example. It can recognize two kind of keywords, yes and no, and again, it's so the board is still attached to my PC. You see, it's recognized. This time it shows a little bit different because in the example, not the board is specified, but actually the device that is on the board. So it basically shows the target device that we are connected to, but in principle, it does not matter if it shows the board or the device as long as everything is correctly recognized. And I now will just basically use the play button to build and then download the project. And you see this is already in a different league. It's not a Blinky with 50 files, which is quite a lot for a Blinky already, but this is a much bigger project, roughly 300 files that need to be built or compiled and then built. And it, of course, takes now a couple of seconds, but still runs much faster than on my own machine. And I can tell you, I don't have the oldest machine on the planet. So it is really the server power behind it is really amazing. And gives you less time to go for a coffee, which is, well, either good or bad, depends on how much coffee you had already that day. So let's wait for the build to finish. Just a couple of seconds more. And this basically also showcases, some of the amazing partnerships that we have now. Of course, in our ecosystem, ARM's ecosystem is, I think, maybe the broadest that you can imagine for microcontrollers. And together with Google, we made this happen. After this one, and looking at the time, I'm quite confident that we will see it. I will show you an example that we did with Amazon AWS. So there's lots of things going on in the background to make life for developers easier, to make it as smooth as possible, to find code examples, to bring them onto your hardware and test drive them with Keil Studio. So now we're at 295, 6, 7, 8, and here we are. Binary is available for download. Build was successful, and now as I hit the play button, not just the build button, it is automatically downloaded onto the target. It connects to my target, resets, erases the sectors, and then flashes it. Again, also flashing, of course, takes a little bit more time as it's quite a big project, but still, for something that is flowing through the web onto your PC via USB, I think this is an amazing thing that we didn't have before. I mean, some of you might know the good old days of the ARM online compiler, where we had already kind of this built in the cloud available, but there was never anything compared with this interactive debugging through the browser. That was unfortunately not possible earlier. Now we have the technology available, and Keil Studio delivers this technology. So just a couple of seconds more. So program is flashed, quick verify step, and then we should see the results in our serial monitor window. So as you can see here, this EVKB, this is our serial monitor where we actually talk to the serial port that is also part of the SMSIS-DAP implementation from NXP. And now, so this little thing here just below the Ethernet connector, this round thing, this is the actual microphone. And you can now say yes. Demo. No. No. Yes. No. Yes. No. So yeah, you get the principle. So this project actually shows if you are looking for something that can be controlled via voice. It's a quick demo you can use to check your settings. It needs to hear what actually the user is saying, and on the development board, necessary drivers are there, package, and yeah, as you just saw, I don't know how long did it take, maybe 5 minutes from importing the project up until running on the development board. So this is really amazing. Again, if you want to explore something, this can help you a lot. Somebody says it recognizes your voice, not mine. Yeah, it depends where you put the microphone. I can say a couple of no for you, and let's see if it recognizes. As you can see here, of course, it is very kind of sensitive to being a demo. You really need to talk to the microphone and say no. So otherwise, it either does not recognize anything, or sometimes it hears silence. So it's a demo. It's something that you can develop further. You can take the source code, take a look at it, refine it, work with TensorFlow on it, do some refinements there. Everything is possible. Okay, so this basically concludes the second demo or project that I wanted to show you. And now, before I go to the last one, oh, sorry, I just need to find, and my slideshow, because I want to explain a little bit further what we have next. Just a second. Oh, under construction. Okay, no, it's already ready. So those of you who have received the hardware package, you should have received, of course, the board from NXP, and you should also have received a little Arduino shield from SparkFun with really the latest and greatest from Dialog, or now as they are called, Renaissance Semiconductor, which is basically a Wi-Fi shield. I would have loved to show you this in action. Unfortunately, this is so hot out of the press that we don't have the drivers ready. I promise you in the GitHub repo that has all the hardware setup and everything in there. Once we have the drivers available, I will tell you how to do basically exactly the same example, just with a Wi-Fi connection instead of Ethernet. So for today, I unfortunately have to go back to Ethernet. And as Ethernet is, of course, power hungry because you have to power a couple of chips more, it will not just work with the USB debug connection that I was using so far. So basically, you need to supply 5 volt to the board via the USB port next to the Ethernet. First, please make sure that this jumper here, the J1, is set to 3.4. So the second from the top is 3.4. You need to close that, and then you can again connect the debug port, and then you are here. Sorry, I just see that I'm talking to the wrong slide. So this is the actual slide that I was talking to. So how to connect it. And then, of course, the last connection that you need to make is connect an Ethernet cable that is hopefully connected with your router at home or in your office, wherever you are today, and try to do this. Connect that as well. So this is the basic hardware setup, and what am I going to show you today is this reference code example, and I have basically the great pleasure to introduce you really as a first time thing here to the Cloud Connector that was created by AWS themselves. As I said, we are working making more soft from the ecosystem, and AWS is one of those ecosystem partners that we have teamed up with since a couple of times, and they have actually on the weekend just for this workshop started to basically publish their software packs that are used in this example project. So the Cloud Connector, and actually also the application, so the Mqtt connectivity application that is used here is done by AWS. We are using ARM Mbed TLS to secure the networking interface. All of this is running on top of FreeRTOS. So the first Blinky that you saw was based on our own Keil RTX. But this one is now just using FreeRTOS as also delivered by AWS. And of course, we use the device and board drivers, HAL drivers from NXP. So you see this whole package is made up of all different components from many vendors. And they all support the CMSIS-Pack concept and the standardization of APIs. And this is what we are using here. So I stop the slideshow again, and I go back to keil.com. And of course, I go again back to the hardware, and I search for the 1050 again. I use the MDK one, and then we see a couple of Mqtt demos. We have Mqtt demos for all the great cloud service providers, and here for AWS, you see we have even 2 demos. We have one for RTX. Our Keil RTX, and based on our middleware networking stack, so the networking stack that comes with MDK. And we have this AWS Mqtt demo running on FreeRTOS, and this is exactly the one that we are going to use now. So we again start here with creating a project. Keil Studio is loading and will automatically pull that project. And again, takes a couple of seconds. Oops. Just need to prepare something. Okay. And it asked me for the project name. AWS Mqtt demo is fine. It imports the project. And again, presents the README just as usual. Of course, AWS requires an account to be able to connect with their service. This was one of the optional pre-work. I hope you have done that. It's yeah, kind of a difficult task if you just do it via the browser login. We are working with AWS on adding a plugin basically to Keil Studio, where you can then pull all the necessary information from directly into the project. This is unfortunately not ready yet. I promise I give an update on that one as soon as we have it, because this is of course a really cool feature. So you basically just once log in, and then you can manage your things as they are called under AWS. You can manage the certificates for the things and the policies and whatnot is required to make this all happen. This now I have done already using the web interface. And yeah, I need to work on a couple of files. So I now take the workspace view here to find them. I know that they are under Amazon FreeRTOS, under demos and include. And what I actually need to change is the AWS client credential keys.header file and the AWS client credential header file. I will start with the second one, with the latter one, where we basically just have to add two things. This is the Mqtt broker endpoint. So basically the server or the endpoint that you are talking to at AWS. This is usually, I think it's personal to you or to your device. I add that one here, and you need to also tell the endpoint which thing is talking to him. And so it's my thing 02. This is the fancy name that I have given my thing. So this is it. This is it already. I can close this one. And now I go to the keys. And here you actually have to enter two things. You have to enter the client certificate, which is kind of private to this client, to this thing. And in the documentation that I have linked, it is also explained how you need to change that. Unfortunately, it's a bit tricky. The certificate is given in a certain form, and you need to add, for example, all these backslashes here and the /n and all that stuff. But this is explained how to do that. And you also have to enter the client private key. I just copy and paste that in. This is not the device certificate, but the client private keys. So here it's Control-E, and that's the client private key. And once you have done these settings, then you're already good to go with this example. If you had the Wi-Fi shield, you would of course also need to provide the Wi-Fi credentials to be able to communicate, of course, to your Wi-Fi network. Again, this is currently the Ethernet-based demo, so no need for that. And I can again start the build process here. You will see a couple of warnings, but that's okay. It's just warnings, and as all good programmers, we just ignore warnings as long as it's not stopping you with an error. Everything is fine. And you see also this example, 177 files, is a little bit bigger, but already done. So it's, again, this build thing is truly amazing, using all the horsepower on our server. Now it's flashing. And it's now programming, so you still see the artifacts from the previous program. Again, this application is also a little bit bigger, so it takes a couple of seconds. Now, let me just... I bring up another panel here, but now let's go back to Keil Studio first. Still programming, but then we can maybe prepare the AWS part. So if you are talking to the Mqtt client, you have to tell him what kind of topic you are interested in. We are interested in the hash topic, which means actually to any topic that is coming in. And with that, we are set up. Just make sure that you are not using the new console experience. There is something that need to be managed. The old console experience will just show us the Mqtt messages coming in. We are here now in the verify step. And now you see this is already the first message waiting for the network connection. I see my Ethernet LED blinking. So it's now talking to my home router to receive via DHCP an IP address. This is done now. And now, of course, it tries to contact the server or MQTT broker that we have entered. And now you see the messages are going out here. And if we basically go to AWS, we see that my thing pushes some example topics, and it's all our good old hello world. So you can, again, also just in a couple of a couple of minutes, can load a pre-built project that fits to your needs. Like, let's say, in this case, you want to use FreeRTOS, you want to use an Ethernet connection. You just load that in Keil Studio. You enter your credentials, and you can be off running this example just in a couple of minutes. And you see the result in the stereo window, basically kind of a printf UART debugging, but of course also in the AWS IoT console. And I think it does that for a couple of iterations, but it will stop with, yeah, here it says demo finished. So basically now you won't see new things here. So 1907, this is my local time here, 7:07 was the last message received. And then the demo basically stopped. Sorry, here's Keil Studio. So that is the third demo application that I wanted to show you today. One thing that I forgot to mention that was actually on my list. One thing, just maybe if somebody has problems seeing these messages, make sure that the baud rate in the stereo window is set to 115/200. I think by default it's 96K, which is of course not the right one. So if you see troubles or garbled output or whatever, then try to use 115/200 and just rerun the project. Then you should see the output correctly. This is also the same for the other example, for the TensorFlow Lite micro example. Of course, you need to have the right UART speed. And sorry, somebody tells me that I should mention something to you. Okay, so yeah, maybe it's a good hint. if you are in a debug session, this serial monitor won't work for you. So it can just connect to that serial output. If you are kind of running freely using the play button in the debug session, you won't be able to see that serial output in this monitor window. So the other thing that I wanted to show you, just let me quickly close down this one and this one. So I go back to the TensorFlow Lite Micro and set that as my active project. One thing that I started earlier with, or where I just lightly touched on, is the GitHub integration. So you see here already a little 2 mentioned. And this actually means that there are 2 files changed with regards to the actual GitHub repo where you have pulled that project from. And there is already the complete GitHub integration in Keil Studio. So you actually can connect your account in Keil Studio to your GitHub account, for example. And then you can also simply push this stuff onto your account. So I can here I can say that I want to stage all the changes. And then, it tells me the stage changes. I can add a commit message, and then I said first import. Say okay. And then, of course, I can also push that directly to GitHub, and I say push. And that, should be it. So you see head commit, first import 1 second ago. So with this way, you don't even have to basically, go away from your tool. You can do everything from within this IDE, push your changes directly to GitHub, make it available to others, and continue working in your environment. So it's really a single not single purpose. So one environment where you can do all the necessary work that you want to do. One question is here, will the webinar be available for reviewing later? Yes, the webinar is recorded, and we hope to have it live by, I think, tomorrow around this time, something like that. So yes, the webinar is recorded. And basically this is it from my point. Okay, somebody missed the certificates part. That was a little bit fast, I know. Again, it is explained a little on the in this repo. Just let me show you maybe this repo again. So here we are under MDK packs, the Keil Studio workshop Dev Summit 21, where we explain or talk about the hardware. I show the basic hardware setup, pre-work, the required software that we need, and the IMSIS-Pack firmware that we unfortunately need to program onto that board first. And later, the optional pre-work about a GitHub account and AWS account. And here you can click on the slide deck. And this is basically kind of a screenshot slide deck of this webinar. So of course you see the first couple of slides, and then it has explicit boxes which tell you what to do. Go to keil.com, click on hardware, search for 1050 and whatnot. And it also later explains about the AWS Mqtt example, the hardware setup, and it also tells what you need, that your AWS credentials. Here's another link to another documentation that explains how to extract those keys that you need for the example to run. Somebody else says network is down, but I have a cable attached. One question, I have seen that seldomly. If both of your LEDs on the Ethernet socket if they are kind of half lit, so not really full, but half lit and both on, then there was a hiccup. Just try to basically reset the board. So unplug it, replug it, and then just flash again. That should make it work. So it did the trick for me. Sometimes I've also seen that sometimes you need 1 or 2 attempts until you resolve the name or the IP address of that MQTT broker name. But that usually, if it does not for the first time, then it retries 4 times or something like that, and then at the second attempt it always worked for me. So here the instructions, what you need to do, which files to open, and which basically things that you need to enter. This is all in the slide deck, and as said, the recording will be made available tomorrow. Also, what I would like to mention here, a couple of other sessions at Dev Summit. So first of all, the basically the kind of talk that gives the background to this workshop, CI/CD MLOps workflow for IoT endpoint development. You can review that anytime. It's an on-demand presentation actually by Reinhard Keil. And then tomorrow I can really encourage you to also go to that workshop. It's tomorrow at 9:15 Pacific time. IoT DevOps made simple and scalable in the cloud. My colleague and distinguished engineer Jason Andrew is doing that workshop, and he will be going in much further detail about this ARM virtual hardware thing that I was talking about. So he will show you DevOps flows or CI/CD flows that you can use to basically deploy software onto these virtual hardware targets. Let test cases run in the background on CI/CD, and this is also a hands-on workshop. The good thing is it does not require hardware; it's virtual hardware, so it should be much easier to follow than mine. I'm very sorry for that. And you still can sign up. I really encourage you to take a look if you're into cloud native. And now let's blow out all the buzzwords: cloud native DevOps for IoT, ML, embedded applications. Then this is another very nice workshop. And then we have 2 links to blogs that also give you some of the background. It seems some of you still have problems with that certificate thing. So for the workshop, you need to configure a thing in AWS IoT console. And how to do that, we have the instructions here. It's another GitHub repo because we have that. In general, we had our own AWS client packs in the past. And this is a step-by-step instruction how so first of all, you need to set up an account with AWS. And once you have that, here's the step-by-step instruction how to set up the thing, attach a policy, create a certificate, download the certificate, and also to manipulate the certificate. So what I was talking about, you need to unfortunately edit the downloaded files. It's 4 steps that you need to do so that, of course, it's kind of C code compliant and can be used with this project. Now I think I'm definitely at the end of this workshop, hands-on session. Any other questions that I can try to answer? Oh, somebody raised his hand. Yeah, can you? There's one question in the chat window. When can we expect the Wi-Fi shield drivers? If I knew that, I would tell you. It can only be a couple of weeks away. Definitely, I will make them available here on this, or let's say at least show you how to do the project with the Wi-Fi shield through this GitHub repo. So this one, the Dev Summit one, this one. And stay tuned. And now we have 2 hands. It's one is Govind and the other is Emerson.
So Govind, I think if you want to go first.
Yeah, sure. Hi, Christopher.
Hello.
This is Govind here.
Yeah.
Actually, I had one question regarding this MCU Espresso. Actually, what I did was I did the installation and I connected the board, and it detected the board, everything was done. And then I tried to connect it over here onto the cloud. But somehow it started giving me a message that this is an embed VFS. And it was almost half a day. I could really not figure out how to get this board working because it was working on the cloud, but after connecting on to that MCU Espresso, I could not connect to the cloud. But finally I figured it out. There was that embed driver in the device manager of Windows which I had to really uninstall. So is it necessary always to do it that way, or is there some way out?
I'm not exactly sure if I 100% understand the question. So my colleagues tell me that you definitely need to remove that embed driver because it makes it creates all kinds of trouble. Once you do that, it should just work fine. As said at the beginning, to connect to Keil Studio, you definitely need to have that specific firmware file in the DAP adapter available, because maybe to mention what kind of technology we are using. You see here this little USB sign in the tab. This tells you that this tab is connected to USB device. This is using a technology which is called Web USB, and for that technology to work, we need a certain USB endpoint in the DAP. And so this is the reason why you need that correct firmware. And another colleague just said that this embed serial driver you may have had still is not recommended on any version, Windows version higher than 8.1. So if you're running Windows 10, then you should definitely get rid of it because it just creates trouble.
No, but this was actually, I did it with the latest MCU Espresso. So I just installed it just to evaluate the board. And it was not an old driver. It was the latest MCU Espresso that I downloaded and I installed it with the board connected. And after that, I started facing the problem. That means I will not be able to use MCU Espresso and Keil Studio on the same machine.
Let me take that back to NXP. I cannot speak for MCU Espresso, so maybe there's just some misconfiguration thing. So I need to check. I really need to come back to you.
Okay. Thank you.
And then Emerson.
Hi, hello, Christopher.
Hello.
First, I really love your presentation. And second, I was wondering, where are all these files stored in the cloud? Like, I was thinking about it's fine, everything works fine, but I believe sometimes my manager may ask me where all these files are stored. So I was wondering about it.
So when you copy that project over, so if you start in the hardware search and you copy that project over, it creates a new user environment for you, and this project is pulled into that user environment. This is more like a virtual environment, and but you can connect. So, for example, you can connect, as I told you before, you can connect via your GitHub account to GitHub, for example, and you could then store those files that are in your user environment onto GitHub and then do the exchange there. So usually, as this is an online tool, we don't have means of storing the files locally. It's all, so you need to have some kind of GitHub or GitLab or whatever Git service running where you could store your files to. As I hopefully said, that we of course are working on a Keil Studio desktop version. Once we have that available, of course it will change. It will then work just locally on your PC, just like any other IDE, like MBK, for example.
Okay, thank you.
Yeah, great. And then I have just another awesome colleague, Wen, reminded me that I really need to share with you this last slide. Stay connected. So go to keil.arm.com. We have this Discord, ARM software dev. We have the ARM community, and I have added this bit.ly here because the name is just much too big. And please, please, please take our survey. Tell me what you think of this session, how good you rated it. That would be lovely to get some feedback from you guys out there. How this was, and if you want to see more.